Tomáš Spáčil, and I'm the part of the team who's working on a project we called Milieu. Vegetable, like the tomato here on the picture or there on the table. Have you ever wondered where does it come from? Is it free of pesticides, or at what state it was picked, or is it even sustainable, the production of such a tomatoes? Because when growing tomato in a soil, the regular tomato in size of 100 grams requires about 22 liters of water. And compared to hydroponic way of growing tomatoes, which our system uses at chances, it's required just 2 liters of water to grow the same amount. The hydroponic system could schematically look like this or like that, but definitely it requires the expert knowledge to run the system, because you have to take control about a lot of aspects, like pH of the water, electric conductivity of the water, temperatures, humidity, and so on. And this is a really complex system with non-trivial, and it's non-trivial control task to keep it somewhere in boundaries. And that's the point where our system comes in place. And we have introduced the principles of Industry 4.0 into agriculture, which we call Agriculture 4.0. And actually, it allows us to grow hydroponically with ease due to online and real-time measuring and control of the system. And beside that, we are able to handle small crops of the plants individually, and we are able to manage like the whole plant life cycle, document the whole plant life cycle. And our system consists of 3 main parts. The green parts are these ones, and these measures the variables in the controlled environment, like a pH or conductivity and so on. And also they produce the control signal for actuators in the system, which affects directly the environment. And for example, this unit costs about 200 euros, and there is gross margin about 80%, and it's currently being tested. Then there are those blue units, which are responsible for communication between the green units and the cloud, and they are handling the planting scenario or control scenario for such a plant. They are also developed. They cost about 400 euros currently. There is higher gross margin and around 90%, and also are being tested on site currently at one of our customers. And the final part of our system is the cloud. The cloud receives the data from our collection unit, the blue one, and according to the data, is based on artificial intelligence, decides which growing plant to choose to reach the optimal yield of the plants. This growing plant is sent back to our blue unit, and it's distributed over the system at the farmer itself. And also it visualizes the data for the farmer in some appropriate and manageable manner. Our business is considered to be business to business, where in the first run we would like to retrofit the current systems. But later on, we are considering to switch into a franchise model, where we will offer to the customers the whole hardware and software solutions. And that will be focused on a small growing areas like cargoes, old factories, small greenhouses, and possibly sometime somewhere beyond the earth. And beside that, there is another way of making money, that because we have got a lot of sensors in our system, we are gathering data and summarizing the performance of the used fertilizers in a system. So we can then offer this data to the fertilizer manufacturers, so they do not have to run their own laboratories. And of course, there are competitors, but the area is hugely polarized in aspects of the price for the system. Because, for example, the company Hogendorm focus on a huge greenhouses in size of several hectares, and the price is also huge because it's running on industrial computers. And on the other side of the spectra, there are, for example, like the project Octopus, which is the open source project. It's almost for free, but you need to have strong programming skills. And there is, or we couldn't find anything between. So thank you, and join us and love the food you like it now, forever. Thank you.